Our next speaker is something of a rebel, I think, in the scientific community. William Happer is Professor Emeritus in the Department of Physics at Princeton University, and prior to coming to Princeton, he taught at Columbia University and served as director of the Columbia Radiation Laboratory. He has some government experience, some recent and some from about 30 years ago. He served as Director of Energy Research in the U.S. Department of Energy from 1991 to 1993, and then most recently, from 2018 to 2019, he was Deputy Assistant to the President and Senior Director for Emerging Technologies at the White House National Security Council. He told me at dinner last night that he's more convinced than ever after his most recent service that there is a deep state, and it's much worse than it was 30 years ago. He's a co-founder of the nonprofit CO2 Coalition, which seeks to educate policymakers and the public about the vital contribution made by carbon dioxide to our lives and our economy. And I just want to say, I'm also in favor of carbon dioxide. He's a co-founder of Magnetic Imaging Technologies Incorporated, which specializes in the use of laser polarized noble gases for magnetic resonance imaging. He also invented the sodium guide star, which is used in astronomical adaptive optics systems to correct for the degrading effects of atmospheric turbulence on imaging resolution. And I'm hoping he's going to tell me at least what that means. But the author of more than 200 peer-reviewed scientific papers, he's a member of a number of professional societies and associations. His topic today is how to think about climate change. Please welcome Dr. William Happer.
Thanks so much, Tim. Well, I certainly appreciate the honor of speaking to this gathering, getting to know a little bit more about Hillsdale College, which, of course, I knew about before, but not in such detail as I've learned over the last day or two. The title of my talk is How to Think About Climate Change, and let me see if this clicker works. I hope it works. Good, okay. So the first thing the best way to think about the frenzy over climate is a kind of a modern version of the medieval crusades. You remember that the motto of the Crusaders was Deus vult, God wants it. And it's hard to pick a better virtue signaling slogan than that. But so far, most of the climate enthusiasts have not gone that far. Some have, actually. They claim they're doing God's work. Because decades of propaganda, many Americans, perhaps including some of you here today, think there really is a climate emergency. Those who think that way, in many cases, they mean very well, but they've been misled by decades of misinformation. So as a scientist who actually knows a lot about climate, and I set up many of our climate research centers when I was at the Department of Energy in the early 1990s, I can assure you that there is no climate emergency. There will not be a climate emergency. And crusades have always ended badly. They've brought discredit to the supposed righteous cause. They've brought hardship and death to multitudes, and policies to address this phony climate emergency will cause great damage to American citizens and to their environment. But it's heating up. On February 4th, Bernie Sanders and Alexandria Ocasio-Cortez and Congressman Blumenauer from Oregon introduced legislation, I quote from Blumenauer's website, legislation mandating the declaration of a national climate emergency The National Climate Emergency Act directs the President of the United States to declare a national climate emergency and mobilize every resource at the country's disposal to halt, reverse, mitigate, and prepare for the consequences of this climate crisis. Well, there isn't a climate crisis. There will not be a climate crisis. This is utter nonsense. Okay. It gets worse when you get to the state levels where there's a little less checks and balances. These are remarks made last week by Charles Ismay, the Undersecretary for Climate Change in Massachusetts, and it was made to the Vermont Climate Council. So I'll read it to you. So let me say that again, 50% of our emissions that need to be reduced come from you, the person across the street, the senior on fixed income, right? There's no bad guy left, at least in Massachusetts, to point the finger at, to turn the screws on. And you know, to break their wills so they stop emitting. That's you. We have to break your will, right? I can't even say that publicly. Well, a few days later, Mr. Ismay resigned, and had he not, his governor would have fired him. But that's the way crusades are, you know. This is really not a question of science. This is a question of a secular religion for some. It's a question of money for others. It's a question of power for others. But whatever it is, it's not science. So during the medieval crusades, part of it was against the supposed threat to the holy sites in Jerusalem, but a lot of it was against local enemies. So the medieval Inquisition really did a job on the poor Cathars and the Waldensians of southern France and the Bogomils in the Balkans. And climate fanatics don't know or care any more about the science of climate than these medieval Inquisitions knew or cared about the teachings of Christ. So just about everyone wants to live in a clean environment. I do, I'm sure everyone here does, and this is a photograph, I hope it shows up on the screen, I don't see it just yet, of Shanghai. And that's real air pollution. You can just barely see the bottle opener building in the back through all the haze, and some of this is actually due to burning coal, but a bigger fraction is due to dust from the Gobi Desert. They've had this type of pollution in Shanghai since the days of Marco Polo and long before. And part of it is burning rice fields, the stubble in the fields, which is traditionally done there. And this is the kind of thing that I do not support. I wouldn't want to live in a city like that, and if there's anything to do that will make it better, I would certainly support that. But none of this has anything to do with CO2. CO2 is a gas you can't see, smell, or taste. So harebrained schemes to limit emissions of CO2, which is actually beneficial, as I'll explain a little bit later, will only make it harder to get rid of real pollutants like the pollutant I showed you in Shanghai. So let's talk about CO2. Number one, it's not a pollutant at all. We breathe out lots of CO2. Many people are surprised to learn that they exhale about 2 pounds, a little more than 2 pounds of CO2 a day. So you people in this room are putting out a lot of CO2. I actually brought a CO2 meter here, which I'm going to turn on. It takes about 30 seconds to warm up, but we will see what the levels are. Before I came down here, my wife Barbara and I measured the CO2 on our balcony outside, and it's about 400 parts per million outside this building. So this is warming up now. I'll show what the results are here in a minute. But our breath is not that different from the output of a power plant. Power plants take in normal air and they burn a fair amount of the oxygen out of the air in burning coal or natural gas or oil. And the result that comes out of the stack is mostly the nitrogen that was already there, a little bit of oxygen that wasn't used up, and water vapor and CO2. And our breath, except for having a lot more oxygen, so you can give mouth-to-mouth resuscitation, you couldn't do it if your breath was like the power plant. It's very similar to the power plant. It's about 4% CO2, 6% water. Power plant has a bit more CO2 and a correspondingly less oxygen. But our breath is definitely not a pollutant. In fact, our breathing reflex is entirely determined by CO2. It's not determined by oxygen at all. It's not a lack of oxygen. It's too much CO2 that makes you exhale. This is a picture of my wife, Barbara, in New Jersey, and a new solar farm. And we've just seen how well solar farms and windmills work in Texas. And they never did work terribly well, but that we have to be grateful for nature. She seems to have a sense of humor and has taught us a good lesson, I hope, although people seem to be slow learners. But the problem with renewable energy, solar, wind, is they take up a lot of space. I preferred this field when it was nice and green instead of these weedy panels. It's quite weedy now. This was soon after it was built. They don't work at all at night, so you need something else to provide power, electrical power at night. They don't work if it's a cloudy day. They don't work terribly well in the winter when the sun is low. So it's pure virtue signaling. They make no economic sense unless you're massively subsidized by the state and federal governments. Here is an early wind farm in California. It's beginning to fall to pieces, but all wind farms fall to pieces. Nobody quite knows how we're going to dispose of all of this junk when it no longer works. It has much the same problems as solar. When I was a kid, people didn't sit in front of computer screens all day and look at simulations of the world, but you could go outside and, look up at the clouds or what the weather was like. And in those days, people knew that the wind bloweth as it listeth. Sometimes it blows, sometimes it doesn't. And we just saw last week it didn't blow very much, and when it was trying to blow, it was blowing on iced up windmill blades and didn't do any good. So renewable energy is really what I would call the inverse Robin Hood strategy. You rob from the poor to give from the rich. Utilities are permitted to raise rates because of the capital investments in inefficient, unreliable renewables. They junk fully depreciated coal, gas, and nuclear plants, all of which are working beautifully, producing inexpensive, reliable energy, but regulated profits are much less. So taxpayers subsidize the rich who can afford to lease land for wind and solar farms. The tax incentives pander to the upper class in gated communities who can afford to buy Tesla electric cars with subsidies from the state and federal government, often subsidies for the electrical power to charge up, their toy. And the common people have little spare income. They pay more and more for the necessities of life in order to subsidize their betters. Now, you can't spend a lifetime as a professor and not relapse from time to time to giving a classroom lecture, so you will have to expect to be lectured to now for a few minutes. And the good thing is there will be no quiz. But as you try to, those of you who share my view that this climate hysteria is nonsense, it helps to know what the facts are. So I hope I can arm some of you with the real scientific facts. This is a picture of the overall circulation of the atmosphere in the Earth, around the Earth. And the thing that keeps us warm on Earth is the sun. Everybody knows that. Things warm up when the sun comes up at dawn, and it's nice and warm, at least in summertime. And the early afternoon, it cools off at night. And the Earth is warm mostly in the tropics, the reddish area on this chart here. That's where the sun is most nearly overhead at noon. And so there's more solar energy coming in at the tropics than goes out as cooling radiation to space. The Earth also radiates, and if you've had dinner here at the Marriott, maybe you sat under some of the infrared radiators on the outside patios, and so you felt the heat, radiant heat. You can't see it, but you can feel the radiation. That's what Earth radiates out to space. So our Earth cools by radiating out into very cold space and by warming up from the sunlight shining during the day, the half of the day. So climate involves a complicated interplay of the sunlight that warms us, the thermal infraradiation that goes out into space, and the transport of this heat by both radiation and by the motion of the air and the water. For example, I think we all know about the Gulf Stream that carries huge amounts of heat to Northern Europe, even to Russia. And these currents of air in the atmosphere also carry a lot of heat. Since we're in Phoenix, let me point out that if you look there, you can sort of estimate where Phoenix is just over the Mexican border. It's where the color changes from yellow to green. And this is the descending branch of the Hadley cell, this air that rises up near the equator, hot air, moist air full of water, so tremendous rainfall down there. And as the air gets really high, 10, 15 kilometers, most of the water has been wrung out, it's been freeze-dried out, and then it heads north or south, and the air that heads north eventually falls back down to the earth, and typically it falls down over Phoenix and over sort of 30 degrees north or 30 degrees south. That's the great desert belts of the earth. That's where the Sahara is, and the Chihuahuan Desert, and to the south, the Kalahari Desert. And so these are regions of Earth which are underneath these cascades of dry air that was produced in the tropics at the equator and naturally went north. It's a giant gas turbine, but driven by the sun and not spinning any windmill blades, at least at those altitudes. Here is a picture of Earth's energy budget. I mentioned we're warmed by the sun. About half of the sunlight eventually gets to the surface. The thing that prevents it all from reaching the surface are clouds. Other parts of America are, like New Jersey now, are covered with clouds, so you don't get any sunlight directly. And some of it is absorbed. But the half that does reach the ground on average heats the ground, and so the ground gets hotter. You can notice that in the afternoon if you go out. And if you're a gardener like me, you can put your hands in the soil, and it's nice and warm, makes the corn grow. And that has to be released. If you keep piling heat up, it gets hotter and hotter and hotter. So it's released by radiation to space, which is that red arrow going up. So the ground transports solar heating upward near the surface for the first few kilometers. A good fraction of that heat is not carried by radiation at all. It's completely immune to anything you do to CO2. But once you get up to 10 kilometers or so, most of that heat transport goes into radiation, this infrared radiation I mentioned. And by the way, I have this running now. The outside air is 400, and I'm not sure you can see this, so I'll read it out to you. It's 580 in here. So what this means, this is not a whole lot higher than the 400 outside. During lunch, we had this out, and it was 1,000 where we were having lunch. But it makes the point that CO2 levels are never stable. People are panicking about 1 or 2 parts per million of CO2. This is, now it's at 608. That's probably because I breathed on it, and, hot air sets it off. These are interesting too. I sometimes take it out on my back porch, and at the end of a summer day, the CO2 levels on my back porch drop to maybe 300, way below the outside air. That's because the trees and grass in my backyard have sucked most of the CO2 out of the air. And then if I get up early the next morning and I look at the meter, it's up to 600. So just from morning to night, CO2 doubles in the air, doubles and halves, at least during the growing season. That's quite common. And we have these hysterics about CO2 increasing by 30 or 40%. It's amazing. Okay, so why the frenzy over CO2? The frenzy over CO2 is because it is a greenhouse gas. That is true. CO2 is a greenhouse gas. This is it's a somewhat deceptive picture, but what it shows in red is sunlight, and the horizontal scale on that top panel is the wavelength of the sunlight. So sunlight is typically about a half a micron, a half a millionth of a meter in wavelength. That's green light, the color of green leaves. And the thermal radiation that cools the Earth is that blue curve to the right of the upper panel, and that's much longer wavelength. That's typically around 10 microns, so it's 20 or 30 times longer wavelength than the wavelengths from the sun. And it turns out that the sun's energy can get through the Earth's atmosphere very easily, so essentially all sunlight, or at least 95%, if there are no clouds, gets to the surface and warms it. But the surface trying to send radiation back out to space is unable to get it freely to space because various gases, most importantly water vapor, which is shown as the third panel down, and CO2, which is the fourth panel down, intercept a lot of that radiation and keep it from freely escaping to space. So this keeps Earth's surface temperature quite a bit warmer than it would be, about 20 or 30 degrees. The Earth would be an ice cube if it were not for water vapor and CO2. And when I say water vapor, you should understand that I really mean water vapor and clouds, the condensed form of water. So clouds are at least as important as greenhouse gases, and they're very poorly understood to this day. Greenhouse gases were discovered in the 1850s by this man. This is John Tyndall, who was a Anglo-Irish physicist working in London. And he was the first one who discovered that water vapor or carbon dioxide or ether or alcohol intercepts thermal radiation. He, as is appropriate for an Anglo-Irishman, his source of heat was a tea kettle. So he had this hot tea kettle boiling on a stove, and then he had a pipe through which the radiation from the tea kettle could go. And he noticed that certain gases, like CO2, or especially water vapor, would block most of that heat radiation, whereas the normal atmospheric gases, nitrogen and oxygen, would not. So we now call the gases that block the heat greenhouse gases, and CO2 is indeed a greenhouse gas. It's not a very good greenhouse gas at today's concentration, so let me show you that. This is something I want you to remember. This is an important slide. So there's a lot of history here, and so there are two pictures here. The top picture is Max Planck, and Max Planck was the great German scientist who discovered quantum mechanics, and amazingly, quantum mechanics goes back to greenhouse gas physics, thermal radiation, just what we're talking about today, and just what climate fanatics don't understand yet, 100 years after Planck. But Planck understood it very well. And Planck was the first one who was able to show why the radiation from warm bodies has the shape it has. On this picture to the left of Planck and below is Schwarzschild, I'll have more to say about Schwarzschild in a minute, is a smooth blue curve. And what that is, again, left to right is wavelength, or the frequency in this case, of light, thermal radiation, and up is the thermal power that's going out to space. And so if there were no greenhouse gases, the radiation going to space would be that Planck curve, that blue curve there. And that would be the radiation that keeps the Earth cool. In fact, that's not what you observe if you look down from a satellite, and we have lots of measurements now. What you see is something that looks a lot like the black curve that's below, with lots of jags and wiggles in it. And that curve was first calculated by Karl Schwarzschild, whose picture is below Planck. Karl Schwarzschild was an officer in the German army in World War I, and he did some of his most creative work in the trenches on the Eastern Front facing Russia. And he, in fact, produced one of the first analytic solutions to Einstein's general theory of relativity while he was there, on the front lines. And alas, he died before he got home, not from Russian bullets, but from an autoimmune disease, which was really tragic. But anyway, Schwarzschild was the theorist who figured out how to calculate how the real Earth works with greenhouse gases in it. It's those jagged black lines. Now, the important point here is that you notice there's also a red line on this chart. What the red line is what would happen if you double the CO2 concentration from today's level. So right in the middle of these curves, I'm sorry I don't have a laser pointer here, but you can see a gap, and that's due to CO2 absorbing radiation that would otherwise cool the Earth. If you double the amount of CO2, you don't double the size of that gap. You just go from the black curve to the red curve, and you can barely see the difference. So the message I want you to understand, which practically no one really understands, is that doubling CO2 almost doesn't make any difference. It goes from that black curve to the red curve, and on the basis of this, we're supposed to give up our liberties. We're supposed to give up the gasoline engines of our automobiles. We're supposed to accept dictatorial power by Bernie Sanders and Ocasio-Cortez because of the difference between the red and the black curve. Don't let anyone convince you that is a good bargain. It is a terrible bargain. The doubling actually does make a little difference. It decreases the radiation to space by about 3 watts per square meter. In comparison, the total radiation to space is about 300, so it's a 1% effect. It's actually a little less than that. And that's with no clouds. Clouds make everything even less threatening. Finally, let me point out there is a green curve. That's what happens if you take all the CO2 out of the atmosphere. No one knows how to do that, and of course, we'd all die because plants die if you take all the CO2 out of the atmosphere. But what this curve is telling you is the greenhouse effect of CO2 is already saturated. That's the jargon in science. It means it's done all the greenhouse warming it can already, practically. And doubling it practically doesn't make any difference. You could quadruple it. It also practically makes no difference. So the CO2 effects are strongly, strongly saturated. Now let me move on. You can take that tiny difference between those curves that I showed you, the red and the black curve, and calculate the warming that should happen. I was one of the first to do this, actually, in 1982. I was the co-author of one of the first books. And you can see On the right panel there is my calculation and lots of other people's calculations since. It's a bar graph of the warming per decade that people have calculated. The red bar is what's actually observed. And on the right is, I think, for 10 years, and on the left is 20 years. But in both cases, the takeaway message is the predicted warmings, which everybody's frantic about, are all grossly over-predicting the warming compared to observation, which is the red bars. So the observed warmings have been extremely small compared to computer calculations over any interval that you look. So it's clear that, all of our policies are based on the models that you see here that don't work. The models don't work. And I think we sort of know why they don't work, but no one is willing to admit it. Here is, let's see, yeah. Here's another demonstration again of that. The red curve here on the bottom is year, so I think it starts in 1975 approximately. It goes through 1925 because some of them are predictions. So the top curve is predictions by the International Climate Alarm Establishment. And the bottom curves are, the blue and the green curves are observations. And so the blue circles are measured by balloons. You probably know that every day thousands of balloons are launched around the world, in North America, Europe, Asia, Southern Hemisphere, and they measure the temperature as you go up. So we know what the temperature of the atmosphere has been doing from these really good balloon records, and it's the blue curves. And the warming observed from balloons is about a third of the warming that has been predicted, by models. And let me also add, nobody knows how much of this warming that's observed is due to CO2. There's good reason to think most of it would be there even without an increase in CO2, because we're coming out of the long little ice age, and we've been coming out of that since the early 1800s, where it got much, much colder. And the green curve is measurements from satellites, very much like the measurements of your, a temporal scanning thermometer. You can look down from a satellite and measure the temperature of the atmosphere. So the satellites and the balloons agree with each other, and they do not agree with the models. This is nice work by John Christie at the University of Alabama, Huntsville. Okay, so for the alleged harm from CO2 is from warming, and the warming observed is much, much less than predictions. In fact, if the warming is as small as we're observing, it's almost certainly beneficial. It gives a little bit longer growing seasons. You can ripen crops a little bit further north than you could before. And so it's completely good news in terms of the temperature directly, but there's even better news, because in reality, by historical standards, we're living in a CO2 famine today. So let me show you that. So this is a picture of our best estimates of past levels of CO2. So the vertical scale, R CO2, is the amount of that CO2 in the past was greater than it is today. And so you can see on that scale that over most of the past, CO2 levels have been 5 times, 10 times, even 20 times greater than today. And during this entire period, this is the so-called Phanerozoic, since the Cambrian era, when we have good fossil records. So we know pretty well what life was doing during that time from the sediments. And all of this period with much higher CO2 levels, life flourished on Earth, and in general it flourished better when there was more CO2. So plants really would prefer to have 2, 3, 4 times more CO2 than we have today. And you can see plants already responding to that. Let me show you an example. This is the greening of the Earth measured from satellites. So this picture shows areas of the Earth that are getting greener over 20-year period, I think. My eyes aren't good enough to read it, but it's roughly 20 years. And what you notice is that everywhere, especially in arid areas, the Sahel, you can see just south of the Sahara, it's greening dramatically. The western United States is greening. Western Australia is greening. Western India is greening. And this is almost certainly due to CO2. And the reason this happens is that CO2 allows plants to grow where today, or where 50 years ago it was too dry. So plants are now needing less water to grow than they did 50 or 100 years before. Let me show you another example of what more CO2 does in terms of making plants grow better. This is a picture of Dr. Sherwood Idsa, and it was actually an experiment done here in Phoenix back in the 80s. And so this is a pine tree that I think it's a Mediterranean pine, Eldarica pine. And on the left is a pine tree growing in the current CO2 levels at that time, which was about ambient was 380, I believe it says. And on the right are more and more CO2. So you can see that the pine trees, the more CO2 you put in them, the faster they grow. And you can do this with almost any plant. You know, corn is wheat, cotton, they all grow better with more CO2. So this is the so-called pollutant that you hear about with the climate emergency. So let me explain the basics of why that works. If you look closely at a plant, take a low-power magnifying glass, you'll see the leaf is full of little holes. And the little holes are to let carbon dioxide diffuse in from the air into the moist interior of the leaf, where the leaf, with a special enzyme called rubisco, one of the most ancient enzymes in the world and the most abundant protein in the world, combines the CO2 with water to make sugar. And the energy to run this little factory, this chemical factory within the leaf, is provided by sunlight. So now the problem with this is if you see this hole, not only is CO2 diffusing in, but there's a lot more water vapor inside the leaf than there is CO2 in the air outside. So for every CO2 molecule that diffuses into the leaf, there are 100 water molecules that diffuse out. So the plant has this dilemma, engineering dilemma. It has to have holes in its leaf to get the CO2 that it needs to live, but those same holes desiccate it, they dry it out, and it, of course, needs water to live too. So what is happening all over the world now is plants grow, they're not stupid, they grow leaves with fewer holes in them, and so there's more CO2 in the air outside, so they don't need as many holes, but they don't leak as much water either. So that's why you're seeing the greening of the earth. It's from the plants themselves taking advantage of CO2 coming back to more historically normal levels. There's more to say about this. There's a second important issue, which is that the enzyme I mentioned, it's called rubisco, is very old. It was probably invented on the evolutionary scale 3.5 billion years ago, so extremely ancient. And at that time, there was no oxygen in the air. And so this poor enzyme was designed in a way that makes it poisoned by oxygen. And so plants today have a hard time when there's not enough CO2 in the air. This enzyme, which is charged to make sugar, instead of making sugar, it grabs from CO2, it grabs an oxygen and it turns the oxygen into things like hydrogen peroxide and other nasty oxidizing things. You've heard of antioxidants in your tea. They're to handle this problem, and that's why they're generated. And so if you have more CO2, this photorespiration is the jargon that goes with that. That is suppressed, and so plants grow a lot better with that. There's a special type of plant called C4 plants, which includes American corn and sugarcane, that has partially solved that problem, but they don't compete well with the old-fashioned plants as the CO2 level goes up. The old-fashioned ones without the adaptation outcompete these C4 plants. Well, you often, when you raise all these issues, the hard scientific issues with your opponents, the fanatics, the response is, how can you say that 97% of scientists agree that there's a terrible emergency here that we have to cope with? Let's see if I can get this back again. There are several things you should say. You should say, first of all, that in science, truth is not voted on. It's not like voting on a law. It's determined by how well your theory agrees with observations and experiments. I just showed you that the theories of warming are grossly wrong. They're not even close. And yet we're making our policy decisions based on these computer models that don't work. So that's one point, is that it doesn't matter how many people say there's an emergency. If it doesn't agree with the experiment, it's wrong. And it's definitely wrong. The second thing is, even when people agree in science, people think of science as, somehow as these incorruptible, priestly people. They're not that at all. They have all the same faults as everybody else, and they're frequently wrong. A good example of that was continental drift. When I was a student in the 50s, nobody with any self-respect in geology admitted to believing in continental drift, although it had been proposed by Alfred Wegener, a German scientist, in the 20s and 30s. And it was based on very good, hard evidence. An example is shown below. There's the fact, for example, that Africa and South America and India and Antarctica fit together like a jigsaw, as though you've taken a jigsaw apart. So that's pretty suggestive, I would say. And secondly, if you look at the fossils in these continents from 300 million years ago, 400 million years ago, they go smoothly from South America to Africa, or from Africa to India, or even into Antarctica. You find fossils of the same organisms, even though there's thousands of kilometers of sea separating them today. And so that again suggests that these were connected. But nevertheless, in spite of this quite persuasive evidence, Wegener was scorned and mocked all his life. He died falling into a crevasse in Greenland, exploring, looking for fossils. So it was sort of a sad ending. But he was absolutely right, and the clincher actually came when we finally declassified the World War II North Atlantic magnetic anomaly data, which we had been sitting on for 10 years, which showed, a conveyor belt of crust being formed starting, mid-Atlantic ridge and going out left and right toward America, toward Europe. So there was absolutely no question that the C4 was spreading. That's the one bit of evidence that Wegener did not have. But he had lots of other evidence that should have persuaded people. So this is just one example. I could tell you many others of scientific consensuses that made no sense. This one is interesting because it had no political background. It was pure science, but it does illustrate the fallibility of scientists and the groupthink that goes in science. If you wanted to advance as a young geologist, you could write a paper scorning Wegener in 1950 and get promoted right away, even though your paper was completely wrong. And once you get tenure, you're there for good. So let me. This is probably a little too long a lecture, so let me bring it to a close, and I'll take some questions. So So the takeaway message is that the policies to slow CO2 emissions they're based on flawed computer models which exaggerated warming by factors of 2 or 3, probably more. That's message number one. So why do we give up our freedom? Why do we give up our automobiles? Why do we give up a beefsteak? Because of this model that doesn't work. And bullet number 2 is that if you really look into it, more CO2 actually benefits the world. So what are we doing? You know, this beneficial molecule that's making plants grow better, that's giving us a little less harsh winters, a slightly longer growing season. Why is that a pollutant? It's not a pollutant at all, and we should have the courage to do nothing about CO2 emissions. Nothing needs to be done. So thank you. I'll stop at this point. Yeah.
Thank you, Dr. Happer. We now have time for some Q&A. If you have a question, please raise your hand and wait for a microphone to be brought to you.
Very interesting conversation. One of the things that the environmentalists always forget is the tremendous amount of CO2 that is produced to get the raw materials, to make the wind turbines, to make the solar cells. But another thing that I have thought about, I've never seen it discussed, every one of those things takes heat out of the atmosphere. Has anybody ever figured that out? The second thing is we talk about the rise of the ocean, of the sea level. Everything we put into the ocean raises the sea level a little bit, and all of the mud that flows off the land raises the sea level. They think it just comes out from glacier mounting, but there's much more complicated than that.
Yeah, thank you. It's true that anything you make in our modern world involves CO2 production, or sometimes the carbon actually goes into the product. Plastics are made of carbon. You know, my coat is made of carbon. With respect to the amount of that, I think it's not negligible, but the biggest source of CO2 is actually burning fossil fuels to get energy for transportation mostly, but also electrical power. Another non-trivial part is cement making. You know, the way you make cement is you take limestone, which is calcium carbonate, and you have to burn oil or coal, and you bake that out, and so you get the CO2 from burning the oil or coal to heat it, to burn the lime. And then when you're burning it, CO2 is coming out, so what you're doing is you're baking CO2 out of the limestone, so you get a sort of double whammy from cement manufacture. I wouldn't call it double whammy, I would call it a double benefit, because as I've said, it's really good, you know, for life on Earth. You know, plants love more CO2. We're happy with more CO2 too. We know a lot about how it affects humans. It doesn't affect us at all. As for sea level started to rise around 1800 at the end of the Little Ice Age. And they've been rising steadily at about 2 millimeters per year. 2 millimeters is not very much, you can barely see it. Well, that's maybe 9 inches a century. You know, if you go to the sea, a typical tide is quite a bit more than 9 inches. So if 9 inches is going to bother you, you've been swindled in the real estate you've got there. So it's nobody knows how long this rise will continue. It could easily go for another century, or it could stop in a couple of years. I was having lunch with someone, and they asked what's interesting in basic science, and one of the more interesting things is speculations that solar activity is beginning to decrease. You know, if you look at sunspot activity, it's definitely less the last few years, and we've had these rather cold winters the last few years, and one of the possible drivers of climate is solar activity. So if there really is going to be a cooling period, we had a cooling period, for example, in the 70s. I remember then reading about the coming ice age and Newsweek and Time, and they flipped immediately, 10 years later. So in physics, we have a joke which says, the hardest thing about a theory is getting the sign right, and that's been true of that's been true of climate for a long time. Anyway, it could cool in another 10 or 15 years. I don't have a strong opinion, but I'm interested in it.
We have a question on the speaker's right.
I understand that the original idea was that CO2 would cause a slight warming, which would cause more water vapor, which was the big greenhouse gas, which would cause still more water vapor and more heating, et cetera, and a runaway situation. The fact that the Earth, that the CO2 its only effect was to increase the temperature and start that cycle, shouldn't have been kind of obvious, since previously the Earth has been a lot warmer and it didn't start to boil.
Yeah, absolutely. The reason the models get these huge numbers, and mine had the same flaw, is because of the water vapor feedback. And I think the reason that those feedbacks are overestimated, and I've worked personally on this, so I know a lot about it, is that they don't treat clouds correctly at the same time. You can't increase water vapor without affecting clouds. And just a few % change in cloudiness completely overwhelms any change from CO2 or water vapor. I mean, we're all familiar with the fact that if it's a hot summer day and a cloud comes over, it cools down. And if you take that on a global scale, it turns out that there's just exquisite sensitivity to cloudiness. Just to follow up on another allusion you made, if there really were this positive feedback, you can't look at the geological history of the Earth, and it could not be as stable. The climate could not be as stable as the geological record indicates if there were these positive feedbacks, because the temperature would be shooting up and down all of the time, for example, because of these changes, solar output I mentioned. But that's not observed. The Earth's climate turns out to be remarkably stable. If there are feedbacks, they're probably negative feedbacks, and they probably involve clouds, is my educated guess.
We have time for one more question.
Yeah, I appreciate the discussion and the knowledge that you passed on. When I look at this issue, though, it's more about marketing and perception than science. Being retired, I have a chance to read these studies as they're published, and I noticed a little trend where they would make a sort of scientific statement about climate change, and 2 or 3 sentences later, then they go into the projected impacts, coastal flooding, deserts everywhere, and so forth. And the media, of course, only reads the first paragraph or whatever they're fed. And so then they publish that, and it just scares the bejesus out of people. And I know I have relatives that believe this stuff. And you try and explain what you're telling us, and with new knowledge, maybe I can do that, but you can't get through to these people. They're just scared from the perception and the marketing. So what do we do?
Well, that's sort of the key question, because the scientific support for it really doesn't exist. But so many people are scared now, and so many people have been brainwashed since childhood. I know I watched our children and grandchildren in school, and they get incessant barrage of the world is coming to an end, you're unlikely to finish your life because you're going to fry, and because your dad's driving an SUV. And, there are a fair fraction of kids who are sufficiently, independent thinkers in every generation that they laugh this off. But there are a lot who take it seriously, and they go home, they can't sleep at night. You've got Greta Thunberg, having hysterics, in front of the mighty of the world. But she doesn't know anything. The amazing thing about Greta, you know, those of you know a little bit about the history of science, Greta's the great-granddaughter of Svante Arrhenius. And Svante Arrhenius was the first person to seriously try to calculate the effects of more CO2. He thought it would be good for Sweden. He was a Swedish chemist, and it would have been good for Sweden. In fact, it is being good for Sweden. Sweden, for example, is getting much higher forestry yields now than it did 50 years ago because of more CO2. But I think he would be appalled to see his great-granddaughter, you know, having hysterics in front of the world for something that he was convinced would be good.
Please join me in thanking Dr. Happer.